And the next presentation is from Peter DB2OS, our chairman, about our recent AMSAT-DL LunART project proposal to ESA, the European Space Agency. As I had already introduced Peter this morning, I propose we jump straight into his presentation. Peter, please go ahead.
Yeah, thank you very much, Matthias, and hello again, everybody. So yeah, let's continue with our brand new proposal for a lunar amateur radio transponder. Okay, so I hope everything is visible here now. Yeah, looks good. I'm not pressing yet. Okay. I hope I have the control now. So I see, I have now the control. So we are discussing now a proposal for a communications platform on the large lunar or large European lander to support communication and payload experiments. So this is actually based on a proposal by ESA. And let's see if we can jump to the next page. Okay, here we are. So, yeah, so what happened? Well, okay, that was not me. I will hope I will get my focus back here, but we will see. So anyhow, so just a few months ago, ESA actually invited for proposals for their large European lander. So they are going to send something to Mars. Sorry, to Mars would be nice, to Moon. And yeah, so they were asking or inviting for payload proposals. So ideas actually at this time. So there will be a European large logistic lander, which is also called EL3. So the 3 for the large logistic lander, EL3. This lander is actually planned for missions, into between 2020 and 2030, but definitely there will be no launch before 2027, so it's still a while to go. But anyhow, they are starting now this process of designing, developing, and now getting proposals. The lander is prepared to deliver around 1.5 tons of mass or payload to locations from the equator to the poles, from the near side to the far side. We will talk what the near and far side is, you will see later on. So now I don't have the control. Okay, now it should work. Hey, I'm doing it. Okay, so what are the elements of this lunar lander? So on the left side, you can see a very raw block diagram. So there is indeed the lander, the descent element on the bottom. Then there is a payload cargo platform element in the middle, and on top of it, we have the payload and cargo segment, so which can carry a lot of stuff. It can be just experiments, payloads, but also ideas for even having a lunar rover, which can be later on deployed from that part. So the total mass or the payload mass will be around 1,500 kilogram. Dimensions of the whole lander is a diameter of 4.5 meters, and the deck height is around 2.5 meters. So this lander actually needs some very important capabilities, which is mainly the night survival, the power and thermal. And it will also provide communication using the standard Ka band relay via the gateway or lunar direct communication to Earth. Here, an interesting part or aspect indeed of this mission is that when we are a payload here, we don't really have to think much about the three top capabilities, meaning power, night survival, and thermal, because that is really a challenge. So what we are proposing is something like a hosted payload, very similar to our payload on SHAL-2. Yeah, some fun facts, because yeah, we have been discussing about ideas putting something on the moon even before in the past, and but it's not that easy as it looks like, because the moon does not have an atmosphere. So the first big challenge is the temperature, and the temperature, depending if you are in the shadow or in the sunlight or in the night or during the moon day, temperatures will be there somehow reaching minus 233 degrees Celsius up to 123 degrees Celsius. So you need quite a well thermal design of this spacecraft, which means kind of insulation, but also some kind of what are you doing in the night when it's really cold? I mean, during the day you get baked, and in the night you will get freezed. So you need very good thermal design, insulation materials, even some sort of active heating during the moon night. Another challenge, well, not such a big challenge for us anyhow, but we already demonstrated that we are able to manage that. So, but yeah, we have a distance here between 363,000 and 405,000 of kilometers. That is due to the orbital mechanics of the moon when it goes around the Earth. So it's not always the same distance, but that means we have a delay from Earth to the moon of about 1.27 seconds, and two-way would be then indeed roughly 2.5 seconds. So when you send a command or when you call someone on the moon, the round trip time is 2.5 seconds. So a little bit much more than the delay you see on Q100. So I guess some people will heavily complain about the echo they will get. So this is also one important point. So is there a dark side of the moon? Because very often, even in the media, they are talking about the dark side of the moon. I guess some people watched a famous movie about that. But in fact, we speak about the near side and the far side. And as you see on this little illumination here on this simulation also, the moon is actually synchronized with the movement of the Earth. So that means we are always looking at the near side, but we never see the far side from Earth. That means if you want to put a payload or whatever on the moon, a spacecraft, a rover, if you put it on the far side, you have no direct communication to Earth. In that case, you always rely on a relaying satellite. So there will be missions, EL3 missions to the near side, but there might be also missions to the far side, and then they probably have to rely on the gateway or even on some additional relaying satellites orbiting the moon. So another interesting fact is lunar libration. As you know, we are looking to the same side of the moon always. So the moon is locked to the Earth, but it's not perfectly. As with always, nothing is perfect. So here you can see an animation of this libration, which means we are not really seeing the same spot on the moon, or the other way. If you put something on the moon with a high gain antenna to the Earth, you have to, either you have to have a wide beam width, or you have to always move the antenna and repoint it to the Earth. Interestingly, it's also nice to know that, in fact, the Russian Soviet probe Lunar 3 was the first one to reach the moon on the 7th of October 1959. And that was the first spacecraft which allowed us also a view to the far side of the moon. So what you see here in the animation is actually means that the longitude and latitude, they reach in the libration reaches an amplitude or deviation in the order of 6 to 8 degrees. So if you have an antenna with a smaller beamwidth, you always need to repoint it. There is also an effect called diurnal libration. That is due to oscillations caused by Earth rotation, but that is less than 1 degree. So night and day on the moon. So as we know, the lunar day is a period of time for the Earth moon to complete one rotation on its axis with respect to the sun. So due to the tidal locking I was speaking before, that also means that the time for the moon takes to take one orbit around the Earth and return to the same place. That's what we are speaking about. So relatively to the fixed stars, the moon takes 27 Earth days, 7 hours, couple of minutes and seconds to complete one orbit. And the average synodic period lasts 29 days, roughly 29 days. So that is actually the length of a lunar month on Earth. So that means, more or less, we have here 29 days of sun, the daytime, and the same amount of days will be night on the moon. So we are talking about approximately 2 weeks day and 2 weeks of night. So 2 weeks, no electrical power from solar cells, no heating, no warming. So you have to survive 2 weeks in the dark, and that is actually a real challenge. So, as I say, the major challenges due to, we call it night survival, that is mainly the power and thermal control of the lunar lander, of the rover, whatever is placed there. Antenna pointing can be an issue that has to be seen how this will be done, either by, as I say, having antennas with at least some kind of directional control, but it depends how the lander lands, where it lands. So you still at least need to have some sort of adjustment, or if you have to have an omnidirectional antenna, your signal will be much less. As I say, the good thing is, if we are something like a hosted payload, if we are part of that mission, power and thermal control will be taken away from us. That is what ESA will take care about. So they have different ideas, concepts, how to do that. They, I think, even discussing nuclear generated power source for the overnight survival, but that is something which will come out of the next studies during the next levels of this project. So, as I said before, this LunART proposal, basically, we found it a couple of weeks ago, and we thought, why not making a proposal to that? So something which will support direct communications through amateur radio frequencies and microwave bands. We hope to support student payloads, which could have direct access to the experiments using amateur radio frequencies. Indeed, everything has to be open, that is clear, have to fit to our amateur radio, ITU rules, and so on. But it would also allow a lot of radio science for the whole community. And our very big factor for us to make it, for the sweet part for ESA is we could also provide backup communication capability to ESA in case of, I don't know, busy or emergency, whatever. So it's always a good idea to have a backup communication capability, and we could provide that actually. So a lot of those things we already learned from previous studies. So as you might know, a couple of years ago, AMSAT-DL together with the DLR, the German Space Agency, we were doing this P5 Moon and P5 Mars studies, where we were looking is how could such a mission be achieved, and how could AMSAT participate in that. At least from that mission, we learned a lot about the communication links, as shown here on the left side picture. So that instead of the AMSAT spacecraft here, that could be then indeed the EL3, the lunar lander. But even with our 20-meter dish here in Bochum, we could provide the uplink and downlink capability as a backup to GSOC, for example, or we could run some other experimental data on this part of the mission. For example, if there will be student payloads, something like that, which have a general interest also to the amateur radio community, we could basically route all the access here and keep the ESA channels free of that stuff. So, as I say, the backup student science data communication is one important thing also for us to get into this part, mainly for public and educational outreach, backup secondary communication, easy access for secondary student university payload, not interfering with ESA infrastructure, and radio science. Indeed, we are talking again about S-band uplink and downlink on 10.5 gigahertz. So this is very similar to what we already have on QO100. Indeed, there will be high-speed data where we might go through the Bochum dish, but we are also thinking about a smaller thing. We call it direct-to-home, to every radio amateur having something like in 1.2 meter dish. Also part of this P5 study we made before was a transponder, which actually a coherent S-band, X-band transponder. So when we started the P5 project, we wanted also the P3E spacecraft to be part of that mission, actually as a demonstrator even before the P5 mission. And our friends from Finland, the AMSAT-DOH team, already started building some hardware. You can see it here on the screen, Michael Fletcher and the whole team. They are really experts in this area. And so they already, or we have already talked about that, and I think they are very enthusiastic to finally see their SX coherent transponder flying on, or hopefully flying on this EL3 mission. So this is a band pipe transponder. It can also be used for SSB communication, but it will allow also ranging experiments, for example, do Doppler measurements, and there should be a lot of interesting stuff. I know Daniel might also be very interested in doing these scientific kind of measurements. So we are also planning some VHF, UHF stuff like linear transponders. Additionally, some low-range communication on the surface of the moon, which includes proximity protocols, LoRa, whatever. These are things really just on the table, which need much more further discussions. This is just something we proposed we could do to make it attractive indeed for the whole process of getting into it with ESA. So even some kind of bidirectional link to the AREX amateur radio station on the Lunar platform, we could think about. Additional, we plan some beacons for radio science up to into the microwave bands, even with very little power, but that has to be seen. But even that could be kind of backup communication, like providing an I'm still alive signal or something similar. So what is the timeline of the whole thing? In May, ESA started this call for ideas online. So Matthias and I, we sit together and we try to get some documents, some work done within a couple of days, because our decision to participate came quite late, but we made it. So in July 2020, there was a deadline for those idea submissions, and this is what they call step 1. So end of July, it was expected that the authors will be notified about the initial idea evaluation, which actually happened. And in August, September, we expect the first review of these outcomes of the proposal. So what is going on now is that ESA is, you can see this here. I will not go too much in the details. If you want to, you can see that later. But it's really a very complex process. It starts here with the authors, with ideas, then they are discussed on the board, internally and externally. They will select the categories. Is it a science outreach experiment? Is it technical infrastructure? So they have coaches for every sections. And then around July, they finally submitted, the final submitted ideas are selected. They go into some further evaluation panels. Then there will be recommendations by the panel to the campaign manager. So somehow at the end of September, but probably even in October, we expect some kind of information if we are still on board, if we passed the step 1 of this review process. So we are waiting at the moment for the advancement to the step number 2. So they will select. They had more than 300 actually submissions, and they are going now to select which one they will look further into this process. So there will be a step 2 process and a step 3. So probably not before October now. If we are lucky and we get into step 2, then there will be further workshops planned. So there's a lot of still documentation to be done and discussions. How could that be really made? So, but it is in the second quarter of 2021. That is actually when the pre-phase IA study will begin. So let's see how far we will get in this process. But as you see, there is a lot of discussion needed still to select those proposals. So what is the latest status about that? So you can see here, we uploaded the proposal on the 3rd of July. I think 1 hour before the end of the deadline. So we were really trying to finish quickly. Yes, and we found very good, how to say, the response was very positive to our proposal, not only in the amateur radio community, but even outside of the community. And you can see here that was one of the initial responses to that the evaluation team really liked the idea. I think they responded. So Lisa from the evaluation team responded, "Thank you for the interesting idea submission. Amateur radio communication represents a very engaging way to involve our main stakeholders." So for ESA, indeed, the main stakeholders are European citizens in lunar exploration. It is a very inspiring idea. So I hope the inspiring idea will make it to the step 2. I can also say from my side, this project is not limited to Europeans. Also, our stakeholders are the European citizens, but in our proposal, we made clear that we are an international community from US to China. We want to involve everyone who has good proposals, good idea, can provide really value to this project. So everyone is actually invited to join us in this project. So that is very, very important to know, I think. Yeah, so fly me to the moon, please. So yeah, I would like to thank also Matthias, who helped me a lot with getting this paper and all the presentations together. It was really on a very short time, but I think we have published the link before. You can even go to this page, online page at ESA, and read all our proposals, the whole documents. So indeed, we are very enthusiastic, but we still have to say, okay, we are still in the phase 1. We are waiting to be selected, and then we have to see how to continue. But I think it's very thrilling, and I think it fits excellently to the purpose of what we are doing, also to include this educational part and so on. And you never know which other doors such project might open. So it's a continuing effort with ESA, with other organizations to keep amateur radio in space. I think that is the most important thing, and we are working on it.
Okay, thank you very much, Peter. I think that was a very good introduction into LunART, and as you said, it was intense, but we are in the game. And hopefully also we get some more positive feedback, maybe in the next couple of weeks. And then the hard work will start. And as you mentioned, we will be happy if other organizations, AMSAT organizations, will join us, whether it's in Europe or even outside Europe, because it will be a big project and we'll need to work together to get this all done. But it will be very interesting, similar like Q100, something completely new. I'm checking on the streams. There was a few questions, but that was rather okay. Do we need to repoint the dish from Q100 to the moon? I propose to rather have a second dish then. And some questions about the link budget. We have, of course, we have made the preliminary calculations, but there is more work to be spent.
Yeah.
And yes, we also have to, as Peter mentioned, we need to know whether we have fixed antennas or we can move them, and there's some uncertainty still there, which will have an influence on the link budget. But very positive feedback, Peter, on both chat channels.
Yeah, as Matthias was pointing out, things like the link budget, we will publish that, but honestly, that really depends on where and how we are placed on this lander, what antennas we can get from them. So this will definitely come as soon as we know how we could be accommodated. But indeed, we are very optimistic in this regard. And yeah, please keep your fingers crossed, and we will keep you informed about the progress here and when we can hopefully start the step 2 or the level 2 of this proposal. That means we will go into workshops with ESA, probably with other interested parties, and get something very interesting together. So yeah, let's see. So thank you very much.
Yes, thank you very much, Peter.